So here we are at the General Assembly of the United Nations, where so many things are discussed and figured out. This is where humanity's future is decided. Hello everyone, I'm Space Mike. I'm a science and space journalist with Borderless Labs, and I love space. I want to fly in space, I want to fly my own satellites and probes in space, and I'm sure there are many of you who want to as well. But aside from learning all of the science, engineering, and math required to do things like that, one of the major roadblocks that make people quit before they even get started is the law. International Trade Arms Regulation. It's the biggest thing that is keeping a lot of these countries from collaborating on space projects that we want to see happen. So we need to talk about it. So what is the clear path to intern at NASA or SpaceX, or build your own satellite and launch it into space? Well, if you're an international student or a non-US citizen who wants to be in the aerospace industry, or if you are a US citizen or a company that wants to do business with a different country, then you're going to want to watch this video. Our team at Borderless Labs consulted with multiple lawyers, lawmakers, and experts from multiple fields to answer questions regarding spaceflight, the law, and international cooperation. We traveled the United States in search of answers, from New York City to Boston to Washington, D.C. and Los Angeles. We didn't get a lot of clarity, but rather conflicting answers and confusion. Now, I've been reporting on SpaceX and rocket science for years now, and this video, this topic, is the hardest topic that I've ever researched or worked on. And I know that NASA and American universities cooperate with international students all the time. So during our quest across America, we met Mason Peck, NASA's former chief technologist and currently a professor at Cornell University, who gave us a tour of Cornell's lab where they've built multiple CubeSats that have either flown in space or will fly soon. And they have international students on their team. Finding out how Cornell and others are legally able to do so inspired us and gave us a path forward to achieve our goals. Our mission is to create online educational content and maker facilities around the world to get students excited about STEAM, science, technology, engineering, art, and math, and give them opportunities to excel in those fields. We want to set up our first lab in Jordan, specifically for refugees, and send them microscopes, telescopes, computers, copiers, scanners, 3D printers, centrifuges. Basically a fully equipped lab to conduct science experiments and engineering projects. Eventually, we want to build our own CubeSat and launch it into space. But the question is, can we actually do that? As an American citizen, there are lots of technologies and products that are restricted under export laws. Most have to do with stuff like weapons and military hardware, which also includes technical data about stuff like that. But we're just trying to get people excited about science and space. Well, it turns out that that doesn't really matter, because some technologies can be converted to cause harm, even space technology. But if we obtain a license for certain exports and control the flow of information, then it should be legally possible. So we need to examine the export laws that control the flow of products and information outside of the United States. ITAR and EAR, the export control regulations run by the US government. ITAR, or the International Traffic in Arms Regulations, is run by the DDTC, or Directorate of Defense Trade Controls within the State Department. And then EAR, or the Export Administration Regulations, is run by the BIS, or the Bureau of Industry and Security, within the Department of Commerce. Both ITAR and EAR exist to ensure that defense or military-related technology does not get into the wrong hands. It's possible, though, to get an export license where the US government is granted permission to transport or sell potentially dangerous items to foreign countries or parties. And these laws exist for good reason. Here I am at the World Trade Center when, on September 11th, 2001, the aerospace industry was hijacked, and aerospace technology was used for evil purposes to cause harm. So this is why ITAR exists, to ensure that technology doesn't fall into the hands of people that would cause harm, destruction, and death. And so, ITAR actually serves a good purpose. And one of the reasons why we're trying to do this is to ensure that nothing like this ever happens again. especially not with spaceflight technology.
So, in a small way, we're trying to act as a preventative, if you will, for kids who could be at risk of being recruited into dangerous groups. But if given opportunities to succeed, we could all collaborate together and enrich all of our lives through progress. In order to collaborate, we want to share knowledge and export the tools that these kids would need in order to make a CubeSat, get internships at NASA, and have a meaningful impact in their lives. But what counts as an export? According to the laws, it includes not just the item in question, but also the technical data about the item. So data about the restricted item and the ability to manufacture that item outside of the US all counts as an export, and thus it's restricted under ITAR. So what exactly counts as an ITAR restricted item? How much of this stuff that we want to send outside of the US is actually restricted? Surely not microscopes and telescopes. But to answer that question, one has to go to the US munitions list, which is divided into 21 categories. I mean, just look at this list. Each category has its own list of items, but all of these, like guns, ammunition, missiles, aircraft, chemicals, they're all obviously weapons, or at least could be used that way. Spacecraft can also be used as weapons, or at least have military applications like spying. As frustrating as that is, it's the law, and you might be surprised at what else is on this list. So for all of our space and science stuff, we're going to be focusing mainly on the 15th, 17th, and 21st categories that cover the related topics. It turns out that the space industry has been interested in these categories for a while, and there have been several reforms over the years to enable the US satellite industry to compete on a global market, because ITAR was hurting their business. ITAR controls exports of hardware, technical data, and defense services designated under the US munitions list. For spaceflight's purposes, these would include the payloads, the satellites, the probes, the landers, and all of their specific systems and components, like a propulsion system or wheels on rovers. Basically anything that will be used on a satellite. The intended end use, or what it's going to be used for, isn't relevant for determining whether or not ITAR applies. Once the item is classified as subject to ITAR, it is always covered by ITAR, even if the final end use is a foreign civil one, like a scientific probe. Satellites are designated as significant military equipment, and consequently, you'd need something called a DSP-83 form signed by a foreign party in order to export that item out of the United States. Off-the-shelf parts are not ITAR controlled, unless some sort of space-relevant modifications are made to the part. However, the technical information, like its drawings and schematics about how to modify a part, that is ITAR controlled even if it's off the shelf. In summary, if a part has been specifically designed or modified for use in a satellite, then it is ITAR controlled. But if a part was originally designed for a non-military terrestrial ground-based system and it can be used in a satellite without any modifications, it's still controlled but not by ITAR. Now it's EAR controlled. With America's worldwide market share in satellite technology declining, reforms had to happen at some point. In early 2013, legislation was passed allowing the removal of some satellite technology from ITAR regulation and added to EAR instead. But more on that in just a minute. Alright, so all of the parts, all of the ITAR controlled items that we're talking about are defined as defense articles, but we need to take a little bit of a closer look at the definition of technical data. For example, there's a document called an ICD, or an Interface Control Document for satellites and launch vehicles, and it includes information about how to make, assemble, or code a spacecraft-related item, and details about the launch vehicles. Some other examples of technical data include the software, classified data, or even tangible articles like models or mock-ups that convey some sort of technical data related to the listed item that's ITAR controlled. However, technical data that is not controlled by ITAR includes any sort of information that concerns general scientific, mathematic, or engineering principles that are commonly taught in colleges and universities. Basically, any information that's out there in the public domain. But also basic marketing information like what an item does, not necessarily how it does it, or what an item is, not how it's made. So yeah, that type of stuff and anything that's in the public domain isn't ITAR controlled, but beware of providing a defense service using information that is in the public domain. And what the heck is a defense service? Well, a defense service is when a party is providing a foreign person, whether they're within the United States or abroad, with any type of assistance, including the training in designing, developing, repairing, maintaining, modifying, or even using a defense article, an item that's controlled under ITAR. And that includes the technical data, like its software. That's all ITAR controlled as well. But other examples of a defense service would be providing any type of training to a foreign military. Any type of training. ITAR applies even if all of the technical data that's used to perform the defense service is in the public domain or otherwise exempt. This is crazy. Here's a couple of examples. If you were to exchange technical emails or teach someone how to repair an ITAR covered item, in order to legally do that, that would require a technical assistance agreement. And then if you were to allow a foreign company to manufacture an item that's ITAR controlled, that requires a manufacturing license agreement. Okay, so even if we're using off-the-shelf components without any modification to get kids excited about science and space, we would still need a license to teach them how to put the parts together and operate it like a satellite. But what licenses you need gets kind of complicated because we've barely talked about EAR yet. On November 10th, 2014, some satellites, spacecraft, and components were moved from the US munitions list, which is ITAR controlled, and were added to the Commerce Control List, which is EAR controlled. And the Commerce Control List is the equivalent of the United States munitions list. Here's a couple of examples. Communications satellites that don't contain any type of classified components or capabilities, that's now covered by EAR. Or remote sensing satellites taking photos or videos of the ground, as long as they have performance parameters below certain thresholds, that's covered by EAR. And then certain subsystems, parts, and components that are associated with satellites and have performance parameters below a certain threshold, like a solar panel that can only collect so much energy, that's now covered by EAR. But you have to go in and look at the list to go exactly what those parameters are. All right, so we're trying to get kids excited about space, and if you're wanting to work on a satellite project or you're building a satellite, to determine whether or not your satellite technology is covered by ITAR or EAR, you have to take a really close look at the different lists. For satellites, under ITAR, it's under their 15th category of the US munitions list. And for EAR, it's under their 9th category of the Commerce Control List. But don't forget about all the technical data in the different separate categories as well. Some examples of ITAR satellites include using imaging, infrared, radar, or laser systems to track ground, airborne, or space objects in real time. Cameras that have more than a 0.5 meter aperture, space-qualified gyroscopes, positioning equipment like GPS, or even attitude control equipment like RCS thrusters. It's a long list of hardware, so where does EAR come in? Basically, the short answer is that most other items that are not specifically listed on the US munitions list, but have the capability to be used for either civilian or military purposes, are considered dual use and are controlled under EAR and the Commerce Control List. The Commerce Control List controls a lot of stuff like chemical and biological weapons, nuclear non-proliferation, national security, regional stability, crime control, anti-terrorism, all that type of stuff. So it's a long list. And the level of control depends on the country being exported to, its destination party, and the end use of the item. And then there's the whole export control classification numbers under EAR. Most satellite technologies are on the 600 series and 500 series of items, which are more strictly controlled than the rest of the stuff on the Commerce Control List, but a lot less strict than ITAR and the United States munitions list. The State Department's summary is that, and I quote, certain commercial communications and remote sensing satellites have moved from ITAR to EAR. The only way to know whether a specific satellite or spacecraft is still under the ITAR is to review it against Category 15 of the US munitions list, which is more specific, more technical, and longer than the previous US munitions list. If your satellite or component is in the list, it's subject to ITAR control. If not, assuming it doesn't appear in the full list either, it'll be subject to EAR control as described in Category 9 of the Commerce Control List. Okay, so if you're a US company and you want to order CubeSat parts from Europe and then send those parts for assembly to, say, the country of Jordan, how does that work? Well, the law clearly states that any sort of foreign-made commodities or items that are bundled with US origin technology, or even foreign-made software that is co-mingled with US origin software, that's all going to be controlled by EAR, and you're going to have to go through the process of getting that export license if there's anything at all that is in any way from the United States. Otherwise, anything else would be subject to retransfer laws. That's a whole nother thing. So, as long as there's no US origin components or software, you might not need a license. But then there's still the technical data, which, even if it's in the public domain, you would still need a license just to talk about it with a non-US citizen. But wait a minute, what about basic scientific research? How do universities or even NASA get away with sharing information with non-US citizens who are either students, interns, or employees without a license? I mean, they still do in certain cases, but a lot of times they don't. Well, apparently there's a special clause for that under the term fundamental research. The Code of Federal Regulations, Title 22, Chapter 1, Subchapter M, Part 120 says, the ITAR specifies that the products of fundamental research are not considered controlled technical data, so long as they are published freely. Fundamental research is defined as university-based basic and applied research in science and engineering, where the resulting information is ordinarily published and shared broadly within the scientific community, as distinguished from research the results of which are restricted for either proprietary reasons or specific US government access and dissemination controls. Research that does not meet the criteria of fundamental research cannot involve foreign persons without export licenses. However, research activities that are considered fundamental typically can involve foreign persons even when they involve the design and construction of defense articles, as the US State Department has deemed such research activities to fall outside the purview of training activities that would constitute the illegal export of a defense service. Oh man, so as you can imagine, this is a very complicated subject with conflicting information within both ITAR and EAR as to what counts as an export and what counts as fundamental research. We've talked to several different lawyers and representatives from the State Department and the Department of Commerce. Everyone that we talked to gave us a different answer. Now, I'm just a beginner when it comes to legalese, the language of the law. So we want to open this up for discussion. And remember, all we're trying to do here is get kids excited about science and space. Here's a couple questions that I have. The kids that we're trying to get excited about science and space, they're Syrian refugees, and one of the countries that you cannot export any of the items or technical data or defense services that are controlled by ITAR, you cannot export any of that stuff to Syria. But now that they're refugees, I mean, does that still apply? I mean, that's a complicated subject there. Another question I have, just for clarity, is let's say I'm doing a Kerbal Space Program video and showing examples of orbital mechanics and Hohmann transfer orbits and stuff like that. I can talk about that stuff. I can make a video about that and upload it for the whole world to see. But is that still technically controlled under ITAR if I wanted to talk to some Syrian refugee students about that same exact thing? Even though I made a video about it and uploaded it for the entire world, would I need an export license to actually have a private conversation with Syrian refugees about publicly available information? I don't know. For our project, for Borderless Labs, as far as providing equipment to Syrian refugees that isn't considered dual use under EAR, we should be allowed to do that without a license. The basic stuff like microscopes and telescopes. But for items that are restricted, even 3D printers, and especially what you can make with them, we'll need to comply with the law. And especially if we're going to be building a CubeSat, we'll need to ensure that we follow the procedures regardless of where the hardware or the data comes from, which may mean getting a license from both ITAR and EAR. We'll need to examine each piece of the satellite on a case-by-case basis to figure that out. Alright, I'm going to put some links in the description down below for all the different reference documents that I was looking up in researching this particular topic, and I've barely scratched the surface. So, especially for those of you who are familiar with all of this stuff, we would love to talk to you about your experiences and how we should best proceed. Because either way, we're going to help these kids, even if that means we can't do everything that we want. But these kids deserve so much more, and we will help enrich their lives through STEAM in any way that we can. Alright, well with that, I guess before the men in dark suits and sunglasses come knocking down our doors, we're making sure that we're doing everything according to the law. We're Borderless Labs, and as our motto states, we're bringing the world together through STEAM. Thank you very much for watching this video. Be sure to like, subscribe, and hit the bell notification so that you're notified anytime I upload a new video. Until the next time I see you guys, be sure to keep moving onwards and upwards, and don't forget, ad astra, to the stars.